Hello everyone, in today's video we are going to cover section 5.2, proving lines parallel. After studying this section, you'll be able to apply the exterior angle inequality theorem and use various methods to prove that lines are parallel. First, looking at the exterior angle inequality theorem, we know an exterior angle of a triangle is formed whenever we extend a side of a triangle to form an angle supplementary to the adjacent interior angle, like this. So I have my exterior angle on the outside, and then my adjacent interior angle on the inside. Now, the measure of the exterior angle is bigger or greater than the two remote interior angles, so the two angles it's not touching. We'll learn later that the exterior angle is actually the sum of the two remote interior angles. Now, identifying parallel lines. Remember, when we cut lines with a transversal, we have 8 angles formed. They're either congruent or supplementary. We also have different angle pairs that are formed, like alternate interior, alternate exterior, corresponding, vertical angles, same side interior, same side exterior, etc. Now, we can prove that lines are parallel if we show that these relationships are either congruent or supplementary depending on the pair. The first one we'll look at in our diagram is angle 3 and angle 6, which are alternate interior angles. So if we show that angle 3 is congruent to angle 6, then our lines will be parallel. So if two lines are cut by a transversal such that two alternate interior angles are congruent, then the lines are parallel. And you can use this short form for your proofs. Alternate interior angles congruent, then parallel lines. Theorem 32 is if two lines are cut by a transversal such that two alternate exterior angles are congruent, then the lines are parallel. So if I show angle 1 and angle 8 congruent, then A would be parallel to B. Again, in proofs, we could use alternate exterior angles congruent, then parallel lines. Now, if we show corresponding angles congruent, then we'll have parallel lines. So if two lines are cut by a transversal such that two corresponding angles are congruent, the lines are parallel. In proofs, we could say corresponding angles congruent, then we have parallel lines. If we show same side interior angles are sup, then we'll have parallel lines. So if two lines are cut by a transversal such that two interior angles on the same side of the transversal are sup, then the lines are parallel. So for a proof, we could use if same side interior angle is sup, then parallel lines. Then if we have same side exterior angles sup, we would have parallel lines. So if two lines are cut by a transversal such that two exterior angles on the same side of the transversal are sup, then the lines are parallel. So in a proof, we could say if same side exterior angles sup, then parallel lines. Now my last theorem, if two lines are perpendicular to a third line, then the original two lines are parallel. So if I have line A perpendicular to line C and line B perpendicular to line C, they'll both create right angles. Notice those are corresponding angles, therefore corresponding angles are congruent. I would have parallel lines. So if I can show that two lines are perpendicular to the same line, then they're parallel. In today's lesson, we learned if a transversal cuts two lines such that corresponding angles or alternate interior angles or alternate exterior angles are congruent, then the lines are parallel. If a transversal cuts two lines such that the same side interior or exterior angles are supplementary, then the lines are parallel. If two lines are both perpendicular to a third line, then the lines are parallel. That's a wrap on today's video. We'll see you in the next one.